Hello everyone. May this day be a step towards fulfilling your most cherished dreams. And always remember, the impossibility of yesterday is a possibility today. Greetings to lecturer engineering design Madam Rosie. Hi, my name is Wong Vui. My matrix number is 07DKM21F1021 and these are my teammates. Alfred Cantino 07DKM21F1025, Elvin Chu 07DKM21F1039 and Jeremy Pahang 07DKM21F1009. It's our pleasant duty to bid you all a genial welcome. Come and join us in this full presentation because our goal is to have everyone have a little introduction about engineering design. We really hope this knowledge may help in future engineering field. Without any further ado, let's start. First and foremost, mechanical engineers are doers and innovators. They design, create, build, and shape the world around us and the world of our future. Design is a key branch of study in mechanical engineering, as it is the process of designing parts, components, and products with an understanding of design constraints and the environment. Design is a crucial branch of study in mechanical engineering and requires a good knowledge of various subjects, including mathematics, engineering mechanics, kinematic, static and dynamic, theory of machine, strength of material, engineering drawing, workshop process. Without mechanical engineering, we would not have things like engines, generators, elevators, or even air conditioning. While we might not even realize it, we most likely use something that has been mechanically engineered every day. Mechanical engineering plays a critical role in manufacture technologies, from cars to airplanes to refrigerators. It enables you to do many daily activities with ease as it brings helpful technologies to our modern society. It is one of the most important subdivisions of engineering because without it, many of the technologies we use every day would not be available. Design in mechanical engineering refers to creating, designing, and building new machines that improve the efficiency of existing ones. Some of the biggest human achievements, from smart cars to the International Space Station, were possible because of the innovative design and unique thinking of the world's top mechanical engineers. As a mechanical engineer working in design, you can create solutions to solve a specific problem or address a particular human need. There are 10 types of design in mechanical engineering design. It is also referred to as machine design. It's classified in these 10 ways. Number one, new design. This design requires technical skills, problem solving expertise, analytical skills, and creative thinking. Mechanical engineers who create, draft, and build new designs are in high demand across industries and workplaces. Adaptive design. In this process, the engineer focuses on adapting existing design. The primary goal here is to make minor modification or alteration to existing product design. Empirical design. Empirical design relies on empirical formula based on past experience and practice. Industrial design. Industrial design is one of the most well-known and commonly used machine design. It involves the production of a mechanical component to address the needs of a specific industrial process. Optimum design. True to its name, it is often the best design to achieve a given objective under specified constraints. System design. System design is the process of designing the complex mechanical system of a complicated mechanical device like a car. It includes designing the various components of the system. Element design. Element design is the design of a specific element of a mechanical system like a piston, crankshaft, bearing, housing, or connecting rod. Computer-aided design. This type of design includes the process of designing using computer software to assist in creating, analyzing, modifying, and optimizing a design.
Now I want to discuss about the designing process. First of all, I will explain about the primary need for designing process. The fundamental elements of the design process include the establishment of objectives and criteria, synthesis, analysis, construction, testing, and evaluation. Thus, the prime purpose of engineering design is to apply scientific knowledge to the solution of technical problems. Next, I will explain about definition of problem in designing. Crucial to solving any design problem is to begin by asking the right question. Use the following questions to help you formulate answer. As example, what is the problem or need? Who has the problem or need? Why is it important to solve? For detailed help with this step, use this research to define the problem, design notebook, and mind mapping. Then I will describe the designing analysis process. Design analysis is essentially a decision-making process in which analytical tools derived from basic science, mathematics, statistics, and engineering fundamentals are utilized to develop a product model that can be converted into an actual product. There are several key steps to process analysis. First, by drawing the flow of process through organization. Second, gather more detailed information about each part of the process and that has been documented. Third, production of an agreed baseline analysis of the current situation. This will include any savings, benefits, and change needs to improve the process. Besides, I will describe about the synthesis designing process. Synthesis involves creatively putting your analysis and research pieces together in order to form whole ideas. The example of synthesis process is it's simply a matter of making connections or putting things together and to help others see the connections between things. Lastly, I will explain the systematic process of comparison and evaluation in designing process. A systematic process involves the definition of a problem, the searching of alternative solutions in general through model. Example of systematic process is a strong example of a systematic process is the scientific method, the synthesis used in laboratories as well as in external setting. Meanwhile, evaluation process go through 4 distinct phases: planning, implementation, completion, and reporting. For example, evaluation process might include what were specific interventions put into place by program to fight the problem being tackled, did the implementation work or not, and how and why. That's all information about designing process. Thank you.
Hi, so today I'm going to talk about the design consideration. I'm going to explain the economic and the production factor of the design. Economic and production factor in engineering design are to minimize product costs. Engineering should consider 3 factors such as the component design, material selection, and manufacturing technique. Next, I'm going to identify the codes and standards used in design. Codes are laws or regulations that specify minimum standards to protect health and safety. Standards are a set of technical definitions and guidelines that function as instructions for designers, manufacturers, operators, or users of equipment. Next, I'm going to talk about the safety and the product liability. Safety in engineering design begins with identifying possible hazards that could occur as well as the corresponding system states that could lead to an accident or incident in the design system. Product liability can include examples such as injuries caused by footwear with inefficient traction, faulty machinery, tools that don't perform as required, defective recreational product and playground equipment, and in one case, firearms that were proven to have a faulty fire control system. Next, I'm going to explain about the environment and the sustainability. The environment in engineering design can perform many functions such as create visual wayfinding solution, enhance a sense of community and identity, and can communicate other important sets of information. It helps providing solution and designing systems. Sustainability engineering is the process of designing or operating systems such that they use energy and resources. Sustainability, in other words, at a rate that does not compromise the natural environment or the ability of future generations to meet their own needs. Lastly, I'm going to talk about propose appropriate design consideration when designing product. We need to identify the problem we are trying to solve, plan for long-term product support, and design for the greater good. The designs need to be better in functionality, cost, safety, and environmental impact.
Next, I will explain about the ergonomic factor in design. Firstly, the definition of an ergonomic relationship between human and machine is term taken from Greek word ergon, meaning work, and nomos, meaning natural law. The goal of ergonomic is to make work more comfortable and improve both health and productivity. It is an interdisciplinary science of designing the job, product, and place to fit the worker. Psychology, industry engineering, computer science, biomechanics, and safety engineering all play a role in ergonomic. Next is the relationship of basic ergonomic between human and machine in the display element. There are 5 basic ergonomic between human and machine, which is proper viewing distance. The display should be positioned at a comfortable viewing distance from the user eyes, typically between 20 and 40 inches. This reduces eye strains and fatigue, and help prevent neck and back pain. Secondly, appropriate screen size. The size of the display should be appropriate for the user needs and the task at hand. Larger displays are better for complex tasks, while smaller displays are more suitable for simple tasks. Third, adequate display resolution. The resolution of display should be high enough to prevent pixelation and ensure that text and graphics are sharp and clear. Proper brightness and contrast. The brightness and contrast of the display should be set to appropriate level to reduce eye strains and enhance legibility. Proper color and font selection. The color and font selection of the display should be careful choose to ensure that text and graphics are easy to read and comprehend. Next is the ergonomic factor used on simple equipment such as micrometer, microscope, etc. is size and weight. The size and weight of the equipment should be appropriate for the user to handle comfortability. For example, the size of the microscope should allow the user to adjust the eyepiece and focus knob without straining or controlling their body. Secondly, viewing angle and distance. The viewing angle and distance should be adjustable to allow the user to maintain a comfortable posture while using the equipment. For example, a microscope should allow the user to adjust the height and angle of the stage of comfort. Thirdly is lighting. The lighting of the equipment should be adjustable and provide adequate illumination for the user to see clearly without causing eye strain and discomfort. Noise and vibration. The equipment should not produce excessive noise or vibration that should cause fatigue or discomfort for user. By considering this ergonomic factor in the design of simple equipment like micrometer and microscope, user can use them comfortably and safely without experiencing fatigue, discomfort, or strain. This can improve productivity, reduce the risk of injury, and ultimately enhance user satisfaction.
There are 4 types of material, which is metal, polymer, ceramics, and composite. Each type of material properties. Metals, high melting points, good conductor of electricity, good conductor of heat, high density, malleable, and ductile. Polymers, high strength, toughness, resilience, resistance to corrosion, lack of conductivity, and low cost. Ceramic, hard, wear resistant, brittle, refractory, thermoinsulators, electrical insulators, non-magnetic, and oxidation resistant. Composites: high strength, high modulus, low density, excellent resistance to fatigue, creep rupture, corrosion, and wear. 1.5.3 Evaluate factors in material selection to minimize environment impact. Cost: it is not always desirable to look for the most affordable products. One needs to take into account the lifespan or utility of the products. When one buys substandard materials, you may end up having to restore them often, and this ends up being costly. Preferring building materials that will serve you well for a long time will be cost efficient. Climate: another significant aspect of the selection of materials is the climate. Determinants like the average extent of the heat or cold during the year, rain or snowfall, amount of daylight are some points to consider. The construction material should respond to the climate and context. Durability: some materials serve longer and are more repellent to corrosion, moisture, and other environmental conditions. By determining the most suitable material for climate, we ensure that they are long-lasting. It is essential to consult experts when choosing building materials that respond to climatic conditions. They will help us to determine materials that are most suitable as per our requirements. Availability: it is always advisable to acquire easily available materials. The availability of building materials also determines the cost and time for installation. Certain materials are locally available and are challenging to transport. It's better to time saver and work can be completed smoothly. Sustainability: with the evolution of the construction industry, the requirement for building materials is growing and is also accountable for the surge in carbon footprint. The best materials are those that can be reused because they reduce the demand for new materials to be produced in the future. Locally found materials also reduce the transportation hassle and thus reduce the emissions. Maintenance: the most suitable materials are those that are effortless or easy to maintain and manage. Maintenance will aid to preserve the building looking good and new for a long time. Aesthetic appeal: everyone has diverse tastes, aesthetic appeal. Everyone has diverse tastes, specifications, and needs. Hence, if one person considers something charming and attractive, it may not interest the other. Only you know what kind of quality of home, construction, building you would like to live in. The choices you make, as well as your budget, climatic conditions, and various other factors, will determine the materials and appearance or look of the building that one desires. Since a picture is worth 1,000 words, for the moment we arrive at the end of this course. Clearly, engineering design not end here. There will be lots more to explain about the design in engineering. But what about the basic function of the program? We have already treated several topics on which you have to practice a lot, and once you master it, you will be able to create and print your own designs. Engineering involves a creative approach and practical evidence for the design, finish, and final product. A great lightning solution enhances the product from function to perception. Well, I guess time has reached the end. That is all from us. Thank you for lending us your precious ears, and we strongly believe that everyone have a great understanding on our presentation and how to apply engineering design in mechanical engineering field. Thank you.